Hello everyone, in this video we will discuss the step 4, how to set up and unscale the analog output channel. Basically, we will use EL4000 analog output cards. In the previous video, we discussed how can we scale the analog input channels. So basically, this is the key equations to scale the analog input channel. Also, we discussed the analog input configuration, especially for this EL3174. And keep in mind the extended range and the latency range selection, because for different selection, the full range will not the same. In this video, we will mainly discuss how can we unscale the analog channel. For the analog input, we will scale one integer value to a float, a real value. The basic idea to unscale the analog channel, that is reverse this process. We will unscale one real and a float value to an integer tag. The integer tag will be connected to the analog output channel. Okay, firstly, let's go through the analog card. From the TwinCat3, this project, so if we right-click, click this add a new item, we will see under this analog output terminals, that is the EL4000 series, and we will see this is the list for all the analog output cards. The common used analog output card, that is a 4014, that is a 4-channel 0 to 20mA 12-bit current output card, or you can select this EL4104, that is a 4-channel voltage analog output card, that's a 16 bits, or this 4038, that is also a 8-channel 12 bits signed this analog range. Since most of the actuators, they will be controlled by an analog current channel, so the common used analog card, that is this 4014 4-channel 0 to 20mA. Maybe someone will ask, why not choose this 4 to 20mA? That's because for my personal view, this 0 to 20mA that cover that 4 to 20mA. And you can use the calculation way to only output 4 to 20mA. Only things we will lose a little bit of resolution. However, this 0 to 20mA that cover that 4 to 20mA is widely used for the application. Also, in this video, I will specially demonstrate using this 0 to 20mA card output 4 to 20mA. That unscale that portion, we need a special calculation there. Alright, to better understand this 4014, this 4-channel analog output card, let's go to the web page. This is infosys.beckhoff.com, and let's search EL4014. Firstly, let's go to the wiring. Okay, let's select this EL4014. So that is the current analog output. And then let's scroll down, find out the 4014. Okay, this card, that is a EL4014. This diagram. And this card has a 4-channel. So this is the channel 1, output 1 plus and 0. And this is output 2, 3rd channel and 4th channel. It's very clear. And this is a current channel card. It also shows other mainstream analog output cards. For example, this one, 4018, this card has 8 channels here. And since this terminal only has 8 terminals, because of the room is limited, so there's no minus terminals for this 8 channels. We need to use an external terminal to wire the minus for each channel. Here, this 0 is the same 0 of the card power supply. So we need an additional terminal to wire the 0. That's why this 4 channels analog output card is a common used analog card. Alright, let's go to the commissioning. And let's go to the operation modes and the process data. And from here, we will see for the analog EL4014, we will need to output 20 milliamp. So the decimal output that will be 32767. This. So this value will be used for unscale the analog output channel. Basically, this value will be the full range for all the analog output channel. For example, here for this 10 volts, the full range, they all 32767. And then if we go back to the hardware configuration of this module, okay, let's double click this 4014, this analog output channel. Firstly, it shows that is a 0 to 20 milliamp 12 bits analog channel. And if you go through here, there's no specific setting here. That's because this module doesn't have any additional setting there. It's already built in this function, and the scale, that's basically is a built-in and fixed scale range. This is a 0 to 32767. Okay, let's go to the programming wise. Firstly, let's go to the I/O. This is the global variable list. I specially put all the I/O tags in this I/O variable list. Here, let me declare AO spare 01 AAT %. This time, because this is the analog output, so I named the Q. And this is the terminal 6 EL4014. Okay, so we have 4 channels, so I will declare 4 channels here. And because those tags, the name, all of them, they are so similar, so I specially changed this name to 4 rather than 1, just for demonstration. Okay, and let's build. Okay, so let's go to the EL4014. I will pick this channel 4 as the output. If we are going to connect this channel, this AO spare 04D connect to this physical channel, we will double click this analog output and click this link to. And then the only available tags will be shown here. So we will select this AO spare 04D channel. This is the number 4 channel. Okay, select this. Okay, and after this, before we program the unscale code, let's go to the global variable list. Let me declare one control signal. That control signal, that is a 0 to 100% a setting value. This setting value will be unscaled to the analog output channel. Okay, I will name this, for example, RAO output setting, and this is a real value. Okay, let me build. And then let's go to this program PID_code. The program is shown in the screen, that is the analog input scale, and we will program the unscale under. This is the analog output. Okay, to unscale the channel, eventually we will transfer the analog value to the physical channel. Okay, this physical channel, that is the AO, the number 4, the channel. And then the unscale. Firstly, we will output 0 to 20 milliamp. And that's full range, that is 0 to 32,737. That is 32767. So our setting value, that is a GVL, this global value, that is this tag. And this tag that is from 0 to 100, that is unit, that is a percent. When we program this unscale, firstly, this is our analog output setting value. And then we will do over the full range of this value. That is this is the full range of this value. Then after this division, we need to time the full range of this analog full scale. Okay, minus when it's get a 0 milliamp, so that value is a 0. Okay, this is the full range. And keep in mind, currently all those area that is a real, but our physical channel, the analog channel, that need to be an integer value. So after this calculation, we need to transfer all this calculation to integer. This is a real to integer convert. Okay. Save and then compile. Let's see if there's something wrong here. Okay, there's no error. So this is an unscale dealing with 0 to 20 milliamp channel. The next topic is, for this scenario, if you are controlling one actuator, the input of the actuator that is a 4 to 20 milliamp, but your channel that is a 0 to 20 milliamp. That means we need to convert this 0 to 100% this value using this 0 to 20 milliamp channel output 4 to 20 milliamp. So let me show how can we do this unscale. How do we do this calculation equation? Firstly, we need to figure out when the analog channel output 4 milliamp, what the actual this channel value will be. What the integer value we need to give to this analog output. So we need to over 5 on this full range, right? So let's calculate. That is 327. 67 over 5. So that means if you are using a channel 0 to 20 milliamp to output 4 milliamp, so the integer value we need to give to the channel, that is 6553. This is integer value. So that is 6553. So with this value, when we need to output a 4 milliamp to 20 milliamp, we need to program like this. Firstly, this ratio is the same thing. Our setting value, we need to over is a full range first, and then this time we need to time to that 4 to 20 milliamp, which means the range actually is from this 6553 to this full range, right? So we need to do this minus 6553. This is the full range to output 4 to 20 milliamp. And keep in mind, we also need to do this plus 6553. So this whole equation need to transfer to integer. So real to integer. We give the same output, or we change to another one. Okay, this we need to select one of them. This equation is used to output 0 to 20 milliamp. This is used to output 4 to 20 milliamp. Because this analog channel, that's the 0 to 20 milliamp, if we are going to use this analog channel to output 4 to 20 milliamp, we need to use this equation. This comes from one short test video. And in this short test code, we can see this line, that is the analog output. And this channel, that is 0 to 20 milliamp. I'm going to output 4 to 20 milliamp. And this set point range, that is 0 to 100%. And here, it should be 67. There's one type of problem. Okay. And over 5, we get this value. It should be 6553. So keep in mind this. Sorry for this. There's one type of problem. And this is an unscaled equation. And this channel, that is 0 to 20 milliamp. But using this equation, we will output 4 to 20 milliamp. And to test this, to verify this signal, I'm using one actual 4 to 20 milliamp, this analog input channel. That input channel, that is a EL4174. I set 4 to 20 milliamp. And that channel, I selected extended range. And since for the extended range we discussed from the previous video, that 4 milliamp, that is a 0. But for the 20 milliamp, that full range, that is a 30518, no longer 32767. So keep in mind this. That's why the full range here, that is a 30518 here, and times 100%. And from hardware wheel, I connect this analog output into this analog input. So to verify this, once I type in the value, for example, 70%, and through this channel output and connected into this analog input. So this scaled value, this value, AI input 2, it should show the same value as I said. Let me show the online test. So once I go online and I set 80, so this 80 convert to this integer value, and this integer value will transfer to the DAC of this analog output channel. And through this hardware connection, connect to this analog input channel, we will see after this scaled from the input channel. So this input, that is 80. That is the same as this output channel. And now I'm going to set this 80 to 40. Change another value, verify that. Set 40. And once we set, we need to click this button, write 40 into this output setting, and we will see this analog input, it received this 40. So that means this analog output unscale and this analog input scale, they all work. Okay, that is the analog channel output. This is the typical way to unscale the analog channel. For the 0 to 20 milliamp channel, when we unscale the channel, especially for this, if we need to output 4 to 20 milliamp, we need to deal with this special calculation here. You can pick one of these two analog output unscale equation for your application. Alright, that is for this video. That is the analog output unscale program. Thank you for watching. Thank you for watching. If you like this video, please give me a thumb up. If you like to watch more videos in my channel, please subscribe and hit the bell. Thank you for watching.